So the trick on this one is you're going to repeat the binomial. You're going to write this as 8 minus 2i times 8 minus 2i. And then the next thing you do, well, you've got a binomial times a binomial. What's our trick for working on that?
FOIL.
FOIL. First, outside, inside, last. So 64 minus 16i minus 16i again. A minus times a minus is plus. What am I going to end up with here? Hunter, when I multiply 2i times 2i, what will I get?
Negative 4i plus 4i. Oh, I squared.
Perfect. Plus 4i squared. Thank you. Now, somebody help remember, what does I squared equal?
-1.
-1. Thank you, Josh. So these two are like terms. There's the minus 16i and the minus 16i. Let's combine those to minus 32i. Minus 32i. And then this is 64. I squared is -1, so this really becomes a minus 4. Because it's -1 times 4. You could write it in 2 steps. I just like writing it in 1. Make sure you get rid of the I squared. And finally, combine like terms. So 64 minus 4 is 60 minus 32i. Beautiful. How's that one looking? All right. I'm pretty sure if you watched the video, I showed you how to check yourself on the graphing calculator, right? Yeah? All right. Let's just kind of look at that again. Make sure we got this one right. 8 minus 2 times I. Where's I? Does anyone remember? Where was I?
Period.
Second, and then the period, and then right arrow, and then take advantage of the square key over here. Hit that square key. And bam, 60 minus 32i. Now that's checking your answer, but it's not showing me the work. I have no problem with you getting the right answer. I want you to get the right answer. Just make sure you check it afterwards, and if it's wrong, go back and fix it. Nice. All right, let's keep going. A couple more here. Example E. This is a tough one. This is about the hardest they're going to get in the homework. So let's look at this one. It's 9 plus 7i divided by 8 minus 4i. And you're asked to divide. You want to write your answers in the form of a plus bi. So we're going to start, and let's do our little details over here, by multiplying by the conjugate of the denominator. So, well, I guess you're going to multiply by 1 in the form of 8 plus 4i over 8 plus 4i. So we're going to multiply by 1. Does multiplying by 1 change the value of something?
No.
No. Multiplying by 1 keeps things the same. So I can do this. I can multiply by 8 plus 4i, 8 plus 4i. Where do you think the 8 plus 4i comes from? How did I decide on that? Yep. 8 plus 4i is the conjugate of the denominator. So we started out with an 8 minus 4i there. We're going to multiply by the conjugate of the denominator over itself. 8 plus 4i is the conjugate of the denominator. Now that's going to leave you with a lot of foiling out to do. I'm going to go through it kind of quickly, starting with the denominator, because something interesting happens in the denominator. You're going to get 64 plus 32i minus 32i, and then minus 16i squared. One of the bigger mistakes I see people making is that they forget to square that value of I here. You need it, because that's going to turn this into a positive 16. In the numerator, it's going to be 72 plus 36i plus 56i plus 28i squared. Let's clean things up. Now, one of the nice things that happens when you try and do this is in the denominator, right? Those disappear. Those cancel each other out. Wow, that's kind of cool. And in fact, what you're left with is 64 plus what?
16.
Plus 16, because that negative 16i squared becomes a positive 16. Remember, when you square that out, that's negative 1 times negative 16 becomes a positive 16. In the numerator, let's see, that's going to be 72 plus 92i minus 28. Let's combine like terms. That's going to be, let's see what, 44?
Plus 92i.
44 plus 92i over 80. Now keep in mind that the problem is going to ask you for it in the form of a plus bi. There's a couple of things that I kind of feel like doing here, but let me show you this first way, because this is what you're going to use in chapter 10 when we simplify quadratic equations, simplify the answers there. I'm going to factor out a greatest common factor, and to my eyes there's a 4 that goes into both of these. 4 goes into 44 11 times, 4 goes into 92 23 times, and then I've got an 80. So why did I bother with all that? Now you can cancel. You can't cancel before. I know it's a temptation to say, oh, I can cancel the 4 into the 80 or the 4 into the 92. You can't. Not like this. These terms are joined in mathematical matrimony. They're married. And if you break up a marriage, you're going to write homewrecker all over your tests. Don't do that. So let's see. 4 cancels in there 20 times, and that leaves you with 11 plus 23i over 20. Now, that's still not in the form of a plus bi that the book wants, or excuse me, that WebAssign will want. So you can write it as 11 over 20 plus 23 over 20 times I. You don't have to simplify it this way. I kind of encourage that because of what, some other stuff you're going to see. You could split this up and write it as, say, 44 over 80 plus 92 over 80 times I, and then simplify it here. You can simplify directly into here, because you're not canceling into an addition anymore. But this is the answer that they're looking for. My inner child will be doing somersaults if you give me this answer. I'll be really, really happy if you give me that. So try and get as far as you can. I mean, multiplying by the conjugate, hey, that's a point. Foiling them out, another couple points. Simplifying, another point. You know, down to here, another point. You know, down to here, another couple points. So get as many partial credit points as you can on these tests, because I do give them out. I look through your answers very carefully. Okay, just a couple more here to finish up. Take a look at F and G. So I to the 46 and I to the 95th. So the problem, and then details. I to the 46. Our goal here is to rewrite to use I squared. So, I squared. This can be written as I squared to the 23. How come I can write it like that? What happens when I remove this parenthesis here? What happens with the exponents? They multiply, right? Now, this is where you're going to use the one thing that I really want you to know about I, and that is what I squared is. Melanie, remind me, what I squared equal? Negative 1. So that's negative 1 to the 23rd power. Now, I don't need to take out a calculator for this. It's negative 1 times negative 1 times negative 1. If you have an odd exponent, so negative 1 to an odd exponent is going to equal negative 1. If you have negative 1 to an even exponent, what's negative 1 to an even exponent going to equal? Positive 1. Well, is this going to be negative 1 or positive 1?
Negative.
Negative 1. Done. That's it. Now, there's other ways to do this, and I'll give you credit for it. If you know how to do it, by dividing by 4 and looking at the remainder, that's fine. That's great. Nothing wrong with that. I don't do it that way anymore. I used to, because here you've only got to remember one thing. What if you add I to an odd power to start with? That's a little bit more challenging, but you're going to start by rewriting by splitting off I. So that would be I to the 94th times I to the 1st. And then you're just going to work with I to the 94th the rest of the way. So you're going to rewrite using I squared. And by rewrite using I squared, I'm really meaning this part right here. We're going to ignore I to the 1st the rest of the way. It's not going to disappear, but we're going to ignore it. So it's going to be I squared to some power times I. What power do I multiply 2 by to get 94? 47. Which then gives me negative 1 to the 47th power, which is what? It's just negative 1. By our rule up above, negative 1 times I is negative I. Again, you can check yourself on the graphing calculator with these. Now, I'll warn you, sometimes the graphing calculator gives you some funky stuff. It depends on the problem. I have no problem with you checking your answer, but you're not going to get any credit unless I see some work. So check your answer if you like. That's fine, but I should see something like this, or you're dealing with something that's with powers of 4. All right, cool. Comments or thoughts? All right. Good luck with this.